When light travels through space, it is propagating into a certain direction. We will call this direction the Z direction. Then in the plane perpendicular to the direction of propagation, the Z direction, we call this the XY plane, light has been confined, and it means that electromagnetic energy has been confined. And as soon as energy is being confined, it creates a gravitational field. This means that every beam of light is accompanied by its own gravitational field, and when a beam of light passes a gravitational field, for example from a black hole or a huge planet, then the beam of light has been deflected by the interaction between its own gravitational field and the gravitational field of the object the beam of light is passing. Newton's second law of motion represents the product of the mass and the acceleration equals the force. For a gravitational field, we substitute for the acceleration the gravitational acceleration. Using Einstein's E is mc square, we find for the force density caused by an interaction between an electromagnetic wave and the gravitational field with acceleration g, 1 divided by c square times the energy density w times the acceleration. This force density is an extra interaction term, which means that we have two processes at the same time when a beam of light is propagating through a gravitational field. The first 5 terms are the interaction between the electromagnetic fields within themselves, and the 6th term is the extra force density, which has been caused by an interaction between the confined energy of the electromagnetic wave and the acceleration of the gravitational field. This gravitational interaction force density between an electromagnetic wave and the gravitational field has been called as the F gravity index. This equals 1 divided by c squared times the electromagnetic energy density times the gravitational acceleration, and the electromagnetic energy density equals 1/2 times the permittivity times the electromagnetic field intensity square plus the permeability times the magnetic field intensity square together times the gravitational acceleration. When we substitute this interaction force between a beam of light and the gravitational field, indicated here as green, the F index gravity, then we get the total equation for an electromagnetic wave propagating through a gravitational field. The terms in black represent the interaction of an electromagnetic field with itself, which results in a propagation of a beam of light in a direction, and the green term indicates the interaction of an electromagnetic field with another gravitational field. And we have seen already that when two identical fields interact together, the result is a force. Fields cannot interact with different fields. A gravitational field cannot interact with an electric field and will not interact with an electric field. Or a gravitational field will not interact with a magnetic field. But when two gravitational fields interact together, the result is a force, and the force is universal, and all the forces together are the final result of the interactions. And according to Newton's third law, these forces together always have to equal 0. There has to be a universal equilibrium in the universe. It doesn't matter how the force has been created. Is it by inertia? Is it by electric-electric interaction, magnetic-magnetic interaction, or gravitational interaction, or the interactions between Lorentz transformed fields, but the total sum always has to be zero at every location, at every time, in any direction.